We're going to solve quadratic equations now, and we're going to solve them using how many methods? I would say 4 different methods that we're going to solve quadratic equations. And the first one is going to be solutions by factoring. So Chapter 7's focus is the solutions of quadratic equations, which are used in engineering applications, especially those involving physics and motion. So projectile motion, Angry Birds, you know, that's what I mean. But a lot of that occurs in our world. So aeronautics and space flight. So we're going to first talk about what a quadratic equation looks like, and then we're going to solve by factoring using the zero product rule. So first of all, a quadratic equation is one that has a degree of 2, or in other words, it has a squared term. It's not necessary for it to have an x term for it to be quadratic, but it must have a squared term. Then I know it's quadratic. So that's all it must have. It cannot have a cube term, so the highest degree has to be a 2, and it must have that squared term, nothing higher than that. So are these quadratic equations? Well, you know, maybe you can just look at this, but this 3x minus 2 squared means to FOIL 3x minus 2. So when you do, you get a 9x squared here. There's that squared term. And then here you get a minus 6x and another minus 6x, which combines to be a minus 12x. And a minus 2 times a minus 2 is a positive 4. And on the right side, we have equals 4. And we are going to be getting quadratic equations typically with 0 on one side. So we'd subtract 4 from both sides of this equation. And we'd have 9x squared minus 12x. And then equals 0. It doesn't have a constant. But the big thing about this problem is it does have that x squared term. So yes, it is quadratic. This next one, when we distribute this x times the 5x squared, we get a 5x cubed. And then this 3x, and then 7 plus 2x squared. So no matter what I do in this problem to try to get rid of the x cubed term, the degree of this equation is a 3. So this is not quadratic because the highest degree is too large. It can only be a 2. So again, this one, yes, it is quadratic. So now let's go ahead and talk about solving quadratic equations by factoring and using the zero product rule. So the zero product rule says that if you have 2 or more things multiplied together, A times B, and if they are equal to 0, then it has to be true that either A is 0 or B is 0, not at the same time, different times, for that statement to be true. So either this has to be 0 so that 0 times B is 0, or that's got to be 0 so A times 0 is 0. So what we do is we break these up into factors. So this is the difference of squares, x squared minus 16. It factors so that there's an x in the front of each binomial. The square root of 16 is 4, so a plus 4 in one and a minus 4 in the other. And now I have 2 factors set equal to 0. So by the zero product rule, either x plus 4 has to be equal to 0, or x minus 4 has to be equal to 0. And then when I solve this for x, I have to subtract 4 from both sides. So one of the solutions to this equation is x is a negative 4, and the other solution, when I add 4 to both sides, is x is a positive 4. Quadratic equations they tend to have 2 solutions. I just have to warn you that sometimes those 2 solutions are the same answer, so we would say it has a double root. Sometimes the 2 solutions are imaginary answers. So there's all kinds of things that are going to happen here. But whatever you do, don't forget that you can always check your answers. So the original equation was x squared minus 16 equals 0. So if I put a negative 4 in for x and square it, I get 16, and 16 minus 16 is 0. And the other answer was a positive 4. So right here, when I put a positive 4 in for x and square it, I get 16, and 16 minus 16 is 0. Before we do number 2, I'd like to go to number 3, because for some of us, factoring this trinomial might be a little bit easier. So remember, this is an easy trinomial to factor. It's got a 1 in front of the squared term. So I know that the front of each of these binomials has to be an x. And now I'm looking for 2 numbers whose product is a negative 6, and I want them to add to be the coefficient of the x term, which is a 1. See this 1 right here? And those two numbers are probably 3 and 2. Probably the 3's got to be positive and the 2's got to be negative in order for these to add to be a positive 1. Please remember, yes, you could replace this with 3x minus 2x, but when that's a 1 in front of the squared term, you just get to put these in as the factored form. By the zero product rule, the x plus 3 gets set equal to 0, and when I subtract 3 from both sides, one of my answers for this problem is x equals 3. I'm going to come way over here and put that, x equals 3. And then when I set x minus 2 equal to 0, I'm going to add 2 to both sides of this equation, and the other answer is x equals 2. So two answers for this. And remember, the original equation was x squared plus x minus 6 equals 0. So I'm going to put a 3 in here anywhere I see x. So 3 squared is 9 plus 3. I copied this x equals a negative 3 because I couldn't read my own handwriting right here. So x was equal to a negative 3, and I didn't get the negative 3 when I copied this. So I have a negative 3 squared, which is 9, but then I'm going to add a negative 3 to that. So again, negative 3 squared is 9, and when I add a negative 3 to that, I get 6, and 6 minus 6 is indeed 0. I think the 2 is the actual value here, so when I go back in here and I put 2 in here for x, and 2 in for there for x, so I have 2 squared is 4, plus 2 is 6, and so 4 plus 2 is 6, and 6 minus 6 is indeed 0, and I've checked this equation as well. Before we move on, I would like to share with you as we go along that we can also solve quadratic equations graphically. So you see this problem that we just did? I'm going to hit my y equals key. And you see this x squared plus x minus 6? We've done this before together. X to the second power plus x minus 6. And I probably have a really nice window on my calculator right now, a negative 10, 10, a negative 10, 10. And I'm going to hit the graph key, and I'm going to see the parabola that results. And what I'd like you to do is I'd like you to look at this parabola, and I'd like you very specifically to look at that spot where this parabola crosses the x-axis. Count from the origin. 1, 2, 3. Negative 3. Did we get an answer for x of a negative 3? Come on over here. Count to the right side. Positive 2. Did we get an answer for x of a positive 2? Sure enough. Remember that the x-axis is where y is equal to 0. I put this into y equals that. Remember, the equation said x squared plus x minus 6 equals 0, not y. It doesn't say it equals y, it says it equals 0. So I put it in for y. And so the solution to this problem is where it crosses the x-axis, in this case a negative 3 and a positive 2. I'm going to continue to do this with the graphing calculator as we move along. Just, frequently. But let's go back and finish this one before we do. I'm going to go ahead and bring that 0.16 over to the left-hand side of this equation. So it was a positive on the right side by subtracting it from both sides. This is the difference of squares, and I need an x in the front of each of these, and a plus sign in one and a minus sign in the other, and a 0.4 times a 0.4 is 0.16. I'm wondering if you could now, instead of showing the work, if x plus 0.4 equals 0, could you just say to me that x is equal to a negative 0.4? And if x minus 0.4 equals 0, could you just say to me x equals a positive 0.4 to be able to give me both of those answers? That would be very cool if you could not bother with writing down the zero product rule and solve these problems. I think I'm going to go ahead and sneak in the next page and just do this in one video because it's pretty simple. So when you solve by factoring, you make sure to get everything on one side, and 0 on the other. And because I like the 20L squared to be positive, I'm going to move the 15L over to the right side. So I have 20L squared minus 15L. Oh my, I see that I can take a greatest common factor out of this of a 5 and an L. So in the parentheses, I'm going to need a 4L because 5L times 4L is 20L squared, and then a minus 3. And I'm ready now because the zero product rule says set the factors equal to 0. So set this 5 times L equal to 0, and set the 4 times L minus 3 equal to 0, and solve for L. So here I'm going to divide both sides by 5, so one of my solutions is L is 0. Here I'll add 3 to both sides. If you could avoid writing that step, if you could just say that the process of adding 3 to both sides would cause this 3 to go over here on the right and be positive, and then just say I'm going to divide both sides by 4, so my other solution is L is equal to 3 over 4. Again, you should check it. Here I'm going to distribute the minus x times the 43, so that'll be minus 43x, and the minus x times the x, so that'll be a minus x squared. You know, sometimes I like my x squared terms to be positive, so I think I'm going to add x squared to both sides. Let's just do that first. So 9x squared and 1x squared is 10x squared. And you see that 9 and that 43x? If you would allow me to transpose that now, so bring the 43x over here, so it will be a positive 43x, and bring the 9 over, it'll be a minus 9 equals 0. And remember, I'm going to go ahead and do this. The longhand way to do this when you've got a 10 in front of the x squared term is to find two numbers whose product is 10 times the negative 9, which is a negative 90, and they must add to be 43, so I'm kind of thinking 45 and 2. Probably a positive 45 and a negative 2 would multiply to be a negative 90 and add to be 43. But when I use them, I'm going to put the negative 2 first and then the 45. So when I break this down into two terms, I'm going to write it as a negative 2x and a positive 45x. And then I'll bring down my minus 9 and bring down my 10x squared. Remember, now we factor by grouping when there's 4 terms like this. And so the first group has a common factor of 2x that come out of that. And then I'll need a 5x here minus a 1. I think the greatest common factor here is a 9. And sure enough, if I put a 9 there, I'll need a 5x minus a 1 here. Ooh, good. Those are supposed to match. And so 5x minus 1 is a factor, and 2x plus 9 is a factor. Those factors have to be set equal to 0. So when I set 5x minus 1 equal to 0, I'll add 1 to both sides, or I'll throw the 1 over to the right, and then I'll divide by 5. If you can do all of that in your head, that's cool. This 2x plus 9, when I set that equal to 0, the 9 will go to the right and become a negative 9. Then I'll divide both sides by 2, and I'll get a negative 9 halves. When does the booster run out of fuel? When you do this problem, let's see, where t is a time in seconds, when does the booster run out of fuel? And that would be the mass of the fuel supply. So that would be 0 right here. I think it's easier to move the t squared over to the left and make it a positive t squared, and the 6t over to the left and make it a positive 6t, and then the 135 to the left and make it negative. Do you see what I've done? I've moved this over here, this over, and even the 135. And so I believe that the two numbers that multiply to be 135 are 15 and 9. It will have to be a positive 15 and a minus 9. And when I set this one equal to 0, t will be equal to a negative 15 seconds. And when I set this one equal to 0, t will be equal to 9 seconds. Would you please tell me that there's only one answer to this problem? It's the 9 seconds, because time cannot be negative. In our next segment, we'll solve by a different method. This was solving by factoring.